Now today we are going to start, that is bases. Now what is a base? A base is either a metallic oxide or a metallic hydroxide or ammonium hydroxide which reacts with hydrogen ion of an acid to form salt and water only. Say when copper oxide reacts with HCl, it will give CuCl2 plus water. This is a basic oxide and this is your acid. When it reacts, it will give salt and water. Now what is a basic oxide? A basic oxide is a metallic oxide which contains ion O2 minus, which contain an ion, that is O2 minus, and reacts with an acid to form salt and water. They are called basic oxides. This contains an ion, that is O2 minus. The importance of the word only say here, if it is omitted for certain compound which are quite different from basic metallic oxides and hydroxides, would include here in the definition of a base. For example, when lead oxide, that is PbO2, when it reacts with HCl, it will give PbCl2 plus Cl2 gas plus water. Now here chlorine is produced. Now basic hydroxide, it is a metallic hydroxide which contain OH minus ion and will react with acid to give salt and water. Say example NaOH. When it reacts with HCl, NaCl plus H2O. This is the base, this is your acid, and this is your salt and water. This is called basic hydroxide. Now alkali. What do you mean by alkali? An alkali is a basic hydroxide which dissolves in water to produce OH minus. Which dissolve in water to produce OH minus ions as the only negative ions. Say NaOH. On dissolving in water, it will give Na plus and OH minus ion. Now alkali is a base soluble in water. All alkali forms hydroxyl ion in aqueous solution as a negative ion. They turn red litmus blue. All metallic oxide and hydroxide are insoluble except of sodium, potassium, calcium. Now this calcium is slightly soluble. Thus sodium hydroxide, potassium hydroxide, then calcium hydroxide, then ammonium hydroxide. These two are strong alkali. Means on dissolving in water, they will give more and more OH minus ion. These are weak alkali. Now all alkali are bases, but all bases are not alkali. So example, ferric hydroxide and cupric hydroxide. Now they are the bases but not alkali because they are insoluble in water. They are not soluble in water. That's why all alkalis are bases but all bases are not alkali. Now classification of bases. On the basic of their strength, a strong alkali, it undergoes almost complete dissociation in aqueous solution to produce high concentration of OH minus ion. Those alkali which will give more OH minus ion, they are called strong alkali. Now example is sodium hydroxide and potassium hydroxide. As already we have discussed, Now, what is a weak alkali? It undergoes only partial dissociation or ionization in aqueous solution to produce low concentration of OH minus. These are weak alkalis. Now, on the basis of their acidity. What is this? The acidity of a base. The number of hydroxyl ion which can be produced per molecule of the base in aqueous solution, or the number of hydrogen ion with which the molecules of the bases will react to produce salt and water, only known as acidity of base. Example, say sodium hydroxide. It will give Na plus OH minus. This is monoacidic. Now for diacidic, calcium, this is monoacidic. Now for diacidic, calcium hydroxide. It will give Ca2 plus 2 hydroxyl ion. This is your example of diacidic. Now triacidic, example is triacidic. Example is aluminium hydroxide, ferric hydroxide. These are the examples of triacidic base. Now, preparation of base from salt. How these bases are being prepared? From salt, say sodium, when reacts with oxygen, then it will give sodium oxide. Like magnesium reacts with oxygen, it will give magnesium oxide. Now, say action of water on reactive metal. Say sodium, when reacts with water, sodium hydroxide plus hydrogen. Potassium, when reacts with water, it will give potassium hydroxide plus hydrogen. Now calcium, when reacts with water, it will give calcium hydroxide plus hydrogen. Now by the action of water on a soluble metallic oxide, that is when sodium oxide reacts with water, it will give sodium hydroxide. Now, like the same, potassium oxide reacts with water, it will give potassium hydroxide. Calcium oxide reacts with water, it will give calcium hydroxide. Now, double decomposition reaction. What is a double decomposition reaction? The formation of an alkali is when ferric chloride, FeCl3, reacts with sodium hydroxide, it will give H3 plus NaCl. What is this? An aqueous solution of salt with base precipitates metallic hydroxide plus salt. Now by the action of oxygen, when zinc sulfide reacts with oxygen, it will give zinc oxide plus sulfur dioxide. This is what? Metallic sulfide. Metallic sulfide plus oxygen, it will give metallic oxide plus sulfur dioxide. Now decomposition of salt. Say for example, salt such as calcium carbonate. On being decomposed, it will give calcium oxide plus carbon dioxide. Copper carbonate. On decomposition, it will give copper oxide plus carbon dioxide. Now, metal nitrate. Metal nitrate means what? Metal nitrate means what? See, calcium nitrate. It will give calcium oxide plus nitrogen dioxide plus oxygen. Now, ammonium hydroxide can be prepared by simply dissolving ammonia gas in water. That is, ammonia gas with water, it will give ammonium hydroxide. This is also a weak alkali. These are the preparations of alkali. Now properties and bases. Say properties of an alkali is what? Now properties of bases and alkali. They are sharp and bitter test. They change the color of indicator, that is from red to blue. Litmus, they can change litmus paper, red litmus paper to blue. Methyl orange, orange to yellow. Phenolphthalein, colorless to pink. They are soapy substance. They are slippery to touch. These are the properties. Now caustic soda, caustic potash are a strong alkali. We know that alkali reacts with oil to form soap. Alkali reacts with oil to form soap. Since our skin contains oil in the form of fat, hence when we touch caustic soda or caustic potash, a reaction takes place and soapy solutions are formed. That's why these bases are soapy in touch. They are a strong electrolyte. They show a mild corrosive action, slight burn on the skin. Chemical properties. Strong alkali absorb carbon dioxide from the air to form carbonate, that is NaOH. Reacts with carbon dioxide, it will give sodium carbonate plus water. Now bases when reacts with acid, such as calcium hydroxide plus HCl, it will give calcium chloride plus water. Now they precipitate as an insoluble metallic hydroxide when added to a solution of salt of heavy metals, such as, say, when copper sulfate reacts with ammonium hydroxide, then it will give ammonium sulfate plus copper hydroxide. Its color is pale blue. Copper sulfate is aqueous copper sulfate. This is also aqueous. Ammonium sulfate is also aqueous. Now, the hydroxide of zinc, aluminium, lead being amphoteric by nature dissolves in excess of NaOH to give salt, that is sodium zincate plus water. But other hydroxide do not. Only some hydroxides, they are amphoteric in nature. What are those hydroxides? Zinc, aluminium, lead being amphoteric by nature dissolves in excess of sodium hydroxide or potassium hydroxide. But other hydroxide, they do not form this type of compounds. Say, when alkali are warmed with ammonium salt, ammonia gas is given out. Say for example, when ammonium chloride reacts with sodium hydroxide, then sodium salt, that is sodium chloride plus water plus ammonia. That is what, when alkalis are warmed with ammonium salt. Alkalis are warmed with ammonium salt, ammonia salt, then ammonia gas will evolve. This gas will evolve. Okay. Now how we can test that? Acid, the strength of acid. One is called pH. pH stands for potence. Potence means what? It is the power of hydrogen. Now pH of a solution. pH of a solution is what? It is nothing but we can calculate this pH as a minus logarithmic value of H plus ion concentration in the solution. H plus ion concentration in the solution. Say this is your 7 and this side, this is the neutral. If suppose it is less than 7, then it is a weak acid. If suppose it is 1, 2, 3, then if suppose any acid whose strength is, whose pH value is 1, 2, 3, they are called strong acid. Whose pH value is 4, 5, 6, they are called weak acid. Like the same, whose pH value is 8, 9, 10, we'll call weak base. Whose pH value is more than 10, 11, 12, 13, what we'll call strong base. Getting? Now, universal indicator. Universal indicator is a mixture of indicator dyes that gives a spectrum of colors depending on how acidic or alkaline solution is. Universal indicator give different colors at different concentration of hydrogen ion in a solution. For example, universal indicator produces a green color in neutral solution where pH is 7. It changes in a basic solution progressively from blue to indigo to violet as the pH increases progressively from 7 to 14. The color changes in acidic solution is from yellow to pink, then to red as pH progressively decreases from 7 to 1. Getting? Now, what are the importance of this pH in our daily life? Say, our body works within the narrow range of pH that is from 7 to 7.8. Plant and animal also survive in a narrow range. In agriculture, every crop grows better in a particular pH range. For example, rice grows better in slightly acidic soil. For rice, what is the requirement of pH? Slightly acidic. Sugarcane, for sugarcane, neutral. Citrus fruit, alkaline. Say, if pH is less than 5.6 of rainwater, it is said to be acid rain. This water contains acids like sulfuric acid, nitric acid, carbonic acid, which are formed by atmospheric pollutants, mainly sulfur dioxide and oxides of nitrogen. Acid rain reduces the fertility of soil and destroys marine life and causes a damage to monuments. Now, in medicine, certain diseases are diagnosed only on the basis of pH value of blood and urine. In digestive system, hydrochloric acid is produced in the stomach, which helps in the digestion of food. But if it becomes excess, pH falls and pain and irritation occurs. To get rid of this, antacids like milk of magnesia, that is milk of magnesia means magnesium hydroxide, is generally used to adjust those pH. Now, in preventing tooth decay, substances like chocolate, sweets are degraded by bacteria present in our mouth. When the pH falls to 5.5, tooth decay starts. Tooth enamel, that is calcium phosphate. Tooth enamel, that is calcium phosphate. Phosphate is the hardest substance in our body and it gets corroded. The saliva produced by salivary gland is slightly alkaline. It helps to increase the pH to some extent, but toothpaste is used to neutralize the excess acid in mouth. And in this way, toothpaste is preventing the tooth decay. Now, I think you all have heard about the bee stings. Bee stings leave acid in the body. If baking soda, a base, is applied on a stung area, it gives relief. Now see, up to this much today, see dear student, what you all have to do? You all have to read this chapter up to this much nicely, twice or thrice. Then you have to write the question answers properly. Okay, then after that, I'll give you an assignment test from this chapter.